Hi, welcome to the channel where I post challenging math problem daily. If you like this video, just give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today, the problem is suppose x1 equal to tan inverse 2, which is greater than x2 then x3 and so on are positive real numbers satisfying this trigonometric equation. Sine in bracket x n plus 1 minus xn plus 2 to the power minus n plus 1 sine xn into sine xn plus 1 equal to 0 for n greater than 1. We have to find the value of cot xn, and second is we have to find the value of xn limiting x tends to infinite. Okay, so how do we proceed? We'll start from this given trigonometric expression. We have sine x n plus 1 minus sine x plus 2 to the power minus n plus 1 sine xn into sine x n plus 1 is given as 0. So what we can do is we take this expression to the left hand to the right hand side. So what we have here is sine x n plus 1 minus xn equal to minus 2 to the power n plus 1 and then sine xn into sine xn plus 1. Okay, now we divide this sine xn and sine xn plus 1. So we have in denominator we have sine xn into sine xn plus 1, and in the numerator we have sine a minus b, so we can use the formula sine a minus b. So sine a cos b minus cos a sine b. Okay, and in this right hand side we have minus 2 to the power minus n plus 1. Now if we give this denominator to each of the terms, so we get sine xn plus 1 cos xn divided by sine xn into sine xn plus 1 minus, we just distribute this denominator. So what we have here is this sine xn plus 1 terms will get cancelled, and here sine xn term would get cancelled. So we have cos xn by sine xn means cot xn, and this cos xn plus 1 divided by sine x plus xn plus 1, so cot xn plus 1. So we got our trigonometric expression as the difference of two individual terms of cot. So now put n equal to 1. Okay, so okay, so we can do what here is we just do our first okay, put n equal to 1. So we have cot x1 minus cot x2, and here minus 2 to the power minus n plus 1 means 2. Okay, then put x equal to 2, here n equal to 1. So cot x2 minus cot x3 minus 2 to the power minus 3. Put n equal to 3, cot x3 minus cot x4. This is minus 2 to the power minus 4 and so on, putting n equal to n. So we have cot x n minus cot xn plus 1 as minus 2 to the power minus n plus 1. Now we add this expression. So what we have here is this term will get cancelled. So the remaining terms is the first term and the last term. So we have cot xn, cot x1 minus cot xn plus 1, and in the right hand side we have taking minus as common. So we have 2 to the power minus 2, so we can write 1 by 2 square divided by 1 by 2 cube plus 1 by 2 to the power 4 plus so on up to 1 by 2 to the power n plus 1. Okay, now just we just simplify the right hand side first, then we will come to this left hand side. So we have a term starting from 1 by 2 to the power 2 up to n plus 1. So the total number of terms is n. Okay, so we will use the formula of sum of GP. So sum of GP minus is there. So first term, okay, so first term is this, then common ratio. Okay, so 1 minus r is the common ratio. So common ratio is 1 by 2 cube over 1 by 2 square. So we have 1 by 2. So 1 by 2 to the power number of terms. So we have total number of terms is n because it start from 2 to n plus 1. Okay, divided by 1 minus r. This is the expression. So what we have in the right hand side is 1 by 2 and 1 minus 1 by 2 square, and this is 1 minus 1 by 2 to the power n. Okay, so 1 by 2 gets cancelled 1. So 1 by 2 to the power 1 minus 1 by 2 to the power n. So this is the term which is cot x minus 1 divided minus cot n plus 1. Now x1 is given. X1 is given as tan inverse 2. So cot x1 means cot of tan inverse 2. So we can write cot of cot inverse 1 by 2. Okay, so cot x1 is half. So we can write half minus cot xn plus 1 equal to minus half, and this 1 minus 1 by 2 to the power n. Okay, now we just take cot x minus xn minus 1 n plus 1 in that side. So we have cot xn plus 1, and this complete terms will get here. So 1 by 2 in bracket 1 minus half to the power n. So our expression of cot x n plus 1 is this. So what we can do is if we multiply this half, so we have half plus half means 1, and then okay, just I am writing, and this is 1 by 2 to the power n plus 1. So half plus half is 1. So we can write cot x n plus 1 equal to 1 plus, sorry, 1 minus half to the power n plus 1. Okay, so we have to find the expression of cot x n. So just replace n plus 1 by n. So the answer to the first question is 1 by 2 to the power n. Okay, now the second part is we have to put limit n tends to infinite of xn. So just if this whole expression means cot xn equal to 1 minus half to the power n, we can write. So xn equal to cot inverse 1 minus half to the power n. Okay, now if we take the limit as n tends to infinite, so this will become 1 minus, as n tends to infinity, 1 by 2 to the power n tends to 0. So this is 0. So this is ultimately cot inverse 1. Okay, so cot inverse 1 means 5 by 4. So this is the answer to the second problem. Okay, so this is all about today. See you tomorrow.